Okay, so you might have used that time to do the quiz. I'll post these notes as I always do, right? And so we went through, and so here are the solutions to assignment 3, number 7, which was kind of a long, tricky question. I've underlined the values that will be likely be different for your question versus my question, but well, so much work. And then we also went through and did a grade calculation from assignment 2, number 6. So of course these will be on Moodle. Just so I have it on the record here, for calculating grades, right, you've got a percentage, and then your grade is usually, we report it as a percentage, but as long as you convert one of them to a decimal, then it's going to work out. All right, so instead of a review, hey, I'm not even set up here. Wait a second. We were talking about markdowns. That's right. All right. Good. I did post the examples that we're going to go through. They're just from the textbook, so nothing crazy. But it should look something like this, right? So these are the ones that I want to go through, hopefully today. Okay. So I posted those on Moodle, but like I said, I just nabbed them from the textbook. So, okay, so markdowns continued. So, oh yeah, before we kind of get going, for these quizzes, what I'm noticing is that it's marking kind of weird. So, what I want you to do is, I think once the quiz is closed, or maybe just after your attempt, I don't know when it'll show you the answers, but for quiz 1, you should be able to go back and check the answers and check your answers versus those answers. And if you find that you should have more marks than you got, then definitely let me know, right? Just tell me which one to look at. I can always see your quiz. So tell me which one, and then I can go in and I can adjust those marks. I adjusted the marks for the last question on quiz 1 because it was marking it weird. If you had commas in there, for example, which I usually do, it marked it as wrong. So I went through and I adjusted those. But for the quizzes especially, just check the answers, right? And make sure that it's marking, reasonably. And if you find something where you should have more marks than you got, then absolutely let me know, right? And we'll fix that. So now it's on you. All right. So for the markdowns, right, we were talking about formula sheet. Here were our last formulas from this section, right? And just to review, we said, okay, well, I'll just go from left to right because we did talk about all these variables, right? But S subscript R is the reduced selling price. S, we know from before, we worked with it a lot, it's just the selling price right? So the original selling price. And then the ROMDA is the rate of the markdown, rate of the markdown. Right, we had ROMU, right, rate of the markup. And so the rate of the markdown is typically given as a percentage, but for our calculations, right, again, we have to use our decimal version. Moving on, right here, the ROMDA is the amount of the discount over the selling price. What is the discount? It's the original selling price minus the reduced selling price, right? So you can work with all of these, right? So D is the amount of the discount, right? So it should be a $, doesn't look like it. Right. So it's the amount of the discount. And then S is, of course, the selling price, the original selling price again. Okay. So let's see here. I had one example from this section. So I am cheating, I'm just pulling it in here, but it is just from your textbook, example 98. So you might just be able to say example 98 if you have your textbook handy. All right, so we have unknown merchants C and D, ooh, mysterious, sell the same article of clothing for $69.95 and $64.95 respectively. So merchant C sells it for $69.95 and merchant D sells it for $64.95. What? They both advertise that they will match the price offered by any other store on any product that they stock. So our first situation, if D's price is marked down by 20%, what discount rate does C have to give to match that price? Okay. So a little bit tricky, right? So let's just outline everything that we know, right? So here, we're told that merchant C has an original selling price, so S. So here we've got merchant C has an S, and you know what? I'm gonna get a little bit crazy here. Let's use subscripts, right? We usually use subscripts if we have, you know, multiple S's like we do in this case, right? We've got two different sales prices and we want to denote which one came from which. So here, I know this is crazy. This is crazy. I've never done this before in this class. Just stay with me. Merchant C. It's not that wild, right? I'm just denoting it by a subscript C. So the sales price for C is $69.95. Using the same setup here, merchant D, I'm going to denote by SD. I'd be in trouble if there was an a merchant R, but I'd use a capital R instead of a lowercase r. Just remember that they're different. SD has a selling price of $64.95. And again, I'm just going to highlight that what I've done here is I've just denoted it with these subscripts. Okay, so they're in a price matching war. Great, all right. So part A, scenario A for merchant C and D. Hey, this got so secretive. If D's price is marked down by 20%, right? And so again, I'm gonna keep these things separate by using subscripts, right? So here, hold on to your hats. the lambda for D is 0.2 or 20%. So that's what we're told. And then we want to know, what does the reduced price, or maybe what does the discount rate? No, markdowns are not on the quiz, not on this quiz. It'll be on the test next week. Oh yeah, so what discount rate? So what lambda does C have to have in order to match the price? So what we want to do is we want to figure out, well, what is the price after a 20% discount? Okay, so then SR, so SRD, we can do that. I know, getting a little wild here, is SD times 1 minus lambda for D. This is just, I'm just using these subscripts. I don't want you to be thrown off by them. I'm just using them to show that this is all for merchant D, right? So the reduced selling price for merchant D is, okay, so my selling price, the original selling price for merchant D is $64.95 times 1 minus 0.20. So I have $64.95 times 0.8. I'll use 0.80. So the reduced selling price, and because my screen is a little bit laggy today for some reason, I'm not going to jump around too much. I'm just going to do the calculations on the side here. But I mean, you should be able to do these alongside here. $64.95 times 0.8. So their reduced selling price for merchant D is going to be $51.96. Hey, nice to 2 decimal places. Okay. So what we're saying here is that, okay, merchant D put their article of clothing, it's all very nondescript. They put it on sale for $51.96. So what we want to do is, okay, then the question says, what discount rate does C have to give to match D's price? So what does the lambda for C have to be to go from $69.95 to $51.96? Okay. So B, SR for merchant C is going to be S. So the original selling price for merchant C times 1 minus the lambda for merchant C, which this is what we want to solve for. So we're forcing the sale price, right? They have to match that price. We're forcing it to be the same. So $51.96 is, and then they've got their original sales price, which is slightly higher, $69.95. And then we'll be able to solve for the lambda for C. Lambda. Okay. All right. 51.96 divided by 69.95. 51.96 divided by 69.95 is 1 minus the lambda for merchant C. So I get 0.7 for 28162974 is equal to 1 minus the lambda for C. Making the switch here, we've done this quite a bit now, so I expect you to be kind of comfortable doing that, but I can add the lambda over to the left-hand side, and then I can simultaneously subtract the 0.74 from 1. So I get the lambda for merchant C must be 1 minus 0.7428162974. So 1 minus that, make sure you keep all your decimal places. Puts me at 0.257183726. So then merchant C would have to offer a discount, a 25.72% discount, in order to match the price that merchant D is offering. And I'll write that out. Merchant C would need to offer a 25.72% discount in order to match merchant D's sales price. Or sale price. All right, so let's see here. That was part A. Part B, whoop. What if the roles were reversed, right? Same style of calculation, right? So now we're just kind of practicing, right? So what discount rate must D give to match C's price marked down by 20% during a sale? So now C is marking theirs down by 20% and D has to match it. You can see how this is the exact same problem, just kind of roles reversed. The original sale prices or selling prices stay the same, right? And so now we start with the rate of the markdown for C is 20%, and then we'll find out what the sale price is. So we're told that the lambda for merchant C is 0.2. And so the reduced selling price for C is the sales price for C times 1 minus the rate of the markdown for C. So we need to find the new selling price, the reduced selling price. So we've got the original selling price was $69.95. Good. Sorry, I'm trying not to scroll, but it's really hard. Times 1 minus 0.20. So I've got 69.95 times 0.8 is 55.96. I'm pulling a fast one here, but we can probably do 1 minus 0.2 in our heads, right? Times 0.8. So that's the price that merchant D has to match, right? And so here, now the SRD has to be the same as the original selling price times 1 minus the rate of the markdown for D. This has to match, right? They're matching the prices, right? Match the price. Can't remember if I made a note earlier, but I should have. So 55.96 must be equal to, and instead of scrolling, I've got it somewhere here. 64.95 times 1 minus the rate of the markdown for D. So if I divide this out, so 55.96 divided by 64.95 is 1 minus the rate of the markdown for D. 65. I get 0.86158585353, probably etc., is equal to 1 minus the rate of the markdown for D. Same switcheroo here. So then the rate of the markdown for D, merchant D, is 1 minus that 0.86158585353. Oops, that doesn't look like 3. I get 0.13841414647. So in order to match the 20% off that merchant C is offering, right, they would have to offer 13.84% off, right? Merchant D would need to offer 13.84% off to match merchant C's 20% off. Good. Okay. If I asked you to find the amount of the discount, right? The amount of the discount, for example, that merchant D would have to offer, well, if the original price is $64.95 and the new price, the reduced selling price, is $55.96, the amount of the discount is just $64.95 minus $55.96. $64.95 minus $55.96, $8.99. So it's the same. So this 13.84% off is the same as taking $8.99 off. Right? So we don't work with the amount of the discount as much because it's just kind of obvious. The rate of the markdown is the tricky part. Right? So, and I don't know, Abhiraj, I don't know if you heard me, but the rate of the markdowns is not on the quiz, only up to markups. If that makes sense.
Markups, right?
Good.
All right. Thank you.
It's only because I'm looking at the chat and all I can see is, will this be on the quiz? And I'm thinking, no. I'll save it for the test. All right. So that's markdowns. Any questions before we head into the next section?
Yes. In assignment 3, some of them appeared to have a combination of figuring out different discounts, markup and markdown. Is that typical that we might find on the test, not just straight markdown or straight markup?
Yeah, so usually like we could take it all the way from, okay, so a store purchases some item with trade discounts, and then we'd have to find the cost to the store, for example. And then, okay, so then they need to account for the expenses and the profit. What's the selling price, for example? And then they have a sale, and now it's marked down for 20% off. And so you could have a very, very big question like that. I like to break it up into little parts, but yeah, we will be combining markups and markdowns potentially in the same problem. But just, sorry.
I just wanted to say thank you.
Oh, you're welcome. But just remember, markdowns, right? So this selling price, this has the same structure as the net price. The net price is always less than the list price, right? The net price is the list price times 1 minus the trade discount, right? It's essentially the store is getting the reduced selling price of the item, right? And so we've changed the variables that we talk about, but the idea stays the same, right? So the store gets it at a discount, and then when things go on sale, we get it at a discount from the selling price. But yeah, so maybe what we'll do here is, because my dog needs to go outside and it's kind of an appropriate time for a little break, how about we do a break until 11, and then we'll start our new section then. How about that? Just a quick break. We're back. She did really not want to go outside because it's snowing a lot. So I had to force her. All right. Just enough time to grab some water or something. I don't know. Do some stretches if you're good like that. Me, I just end up sitting for, well, I guess I'm up and about, but 4 hours. Okay. So this next section, just as a heads up, we were gonna do section 3.1 and 3.4, but I think I told you guys last day, we're not gonna do it this term. It's the first time that I'm not doing it. And it's okay, it's not on the final exam or anything, so it's just kind of an extra section. And I know what the problem is. It's because we had that week bump right at the beginning of the term, and I like to have the test before reading break. So then we were kind of short on time, but only before reading break, and then we'll have time after. But it's because I like to get the first test out of the way. All right, so section 3.3 is on business economics. I know that's really vague and not very helpful, but section 3.3 is called business economics. Yep. Okay. So here we're going to build profit functions. We've already used profit functions when we introduced, the idea of a function where we put in some value and we get some output, right? And so for profit functions, we're gonna just build them up, okay? And it's the next section on your formula sheet, okay? So I want to take the formula sheet here. So it's called Cdp Analysis, and I think I confessed last day, I never remember what CVP stands for. I think the C is cost, and V might be volume or value. I don't know. And price. It doesn't matter. It doesn't matter to us solving this problem. Otherwise, I would know it. But so what we do is we're going to build profit functions. So in this section, we will build profit functions given some information like the total cost, which is the variable cost. And so if you just kind of read across here, the total cost is the variable cost plus the fixed cost. So, you know, you guys are all in business, and so that should be pretty intuitive. Or at least if I said, hey, what are the total costs? You would probably just tell me, oh, it's your fixed cost plus your variable costs, right? And so here it is in a mathematical way, right? The variable cost, if we drill down on the variable cost is some cost, C, right? We're going to denote it by some C, which gets confusing, right? Because we've got variable cost and then the C, but regardless, the C is the cost times some X, and typically X is the output, the number of units that I'm producing, right? There's some cost to producing each unit X. Okay. Then I can talk about, okay, well, the total revenue is going to be the price, right? So here, TR, total revenue, no surprise there. The total revenue is going to be the price that I charge per item times however many items I have. Notice that this X is the number of items that I'm selling or producing. And we talked about this earlier. In this course, we're going to assume if I make 40, I don't know, handmade signs, making them means I've sold them, right? And that's not always the case. But for us to simplify how we think about things, okay, so if I produce them, I will sell them, right? And we kind of consider them sold in the same at the same time, which is kind of weird, but it simplifies our math, as you might see. Okay. So the price that I charge per item times however many items, that's my total revenue. Now, the profit at X units, right? So the profit of X units, right, depends on how many units I've sold or made or whatever. That's my total revenue, right? So if I asked you, oh, okay, well, and I think, or I'm confident that all of you would be able to handle a word problem like this, right? And so if I told you, oh yeah, I make these signs for, you know, it costs me about $4 to make each sign, but then I sell them for $10 each, right? Okay, so the cost per sign is $4, but then I sell them for $10 each, right? And I sold 20 signs this month. Okay, what's my profit? Well, my profit is going to be 20 times 10 minus the cost that it costs to make them, which is my variable cost and my fixed cost. So here, this is just my variable cost, right? But I also need to take into account my fixed cost. So I know my fixed cost 4 times, you know, per sign. Can't remember what my example was. And then maybe I pay $500 in rent. I would need to take that away from my profit, right? All right. So what we want to do is, so in this section, we'll build profit functions given information about a scenario. So given information given information about the variable costs. So VC is the variable costs. The FC, which is the fixed cost. All right. So what I'm just going to do here is I'm going to go through and define each of these variables here, and then we'll be able to do some examples. So, and then my total cost, oops. The total cost. C is the cost to produce one item, or to produce, oops, to produce, one item. Right, so the per item cost. X is the number of units made / sold. Okay, and I will make a little note here, like I was saying, we assume that these are the same. We assume, that's what an assumption is, right? It can be a little bit weird, but we assume these are the same. All right, if I make it, I've sold it. If I've sold it, I've made it. It doesn't work that way. Well, it does. TR is the total revenue. Total revenue. P, remember, is, so this is a lowercase p. A lowercase p is the price that I charge per unit, right? So you can think of it as the selling price per unit. P is the price per unit, right? The selling price. We will never make connections going between the old selling price and this selling price, right? So we've been working with markups, markdowns, whatever. Yeah, no, we never cross over, right? So if I'm building a profit function, then we use lowercase p for the selling price. The idea is the same, but of course. So then the profit is going to be the total revenue, which we've already defined, minus the total costs. So we're going to build profit functions. Okay, so let's start kind of nice and slow here. And I've got these examples, maybe not nice and slow. Let's start with a huge example. No, it's nice when it's broken up like this into multiple parts. Okay, sometimes it'll just have, right, sometimes if it doesn't hold his hand, our hand through it, it can be easy to get lost, but okay. Again, it's just from your textbook, so example 102. Source Graphics charges $750 to design logos for companies. Pretty good deal, I think. Their graphic designer takes 10 hours for each logo and charges $35 per hour, right? This is per logo. So right away, I'm classifying these costs as, are they variable costs or are they fixed costs? Additionally, the equipment needed to create these logos costs the company a one-time fee of $10,000. We assume that we're here in kind of the first month, right? And so I will say this, sometimes the questions in the textbook and all the questions in general you're going to need to be a little bit flexible on how you read them, right? So when you read this, the equipment needed to create these logos cost them a one-time fee of $10,000. That's going to be one of our fixed costs, okay? So I'm just going to use it as a fixed cost. It doesn't really work that way, but that's how we're going to use it, okay? So, all right. So what I want to do first is I just want to go through and figure out what information I have. And then, well, the first question asks, what's the profit function for a source graphics? Just jumping right in there, right? And so what you'll find that we'll do is we're going to start here, the profit, because this is what we want, right? And then how I like to do it is I like to bloom out, right? So then I substitute my total revenue for P times X, and then I can substitute my total cost, remembering that the variable cost I can calculate, right? And so I just kind of, I start here at the profit function if that's what I want, and it will be. And then I just kind of bloom out and I fill it in. Lots of ways you can do it, but that's how I do it. So let's list the information that we have. So the price that they charge per logo is $7.50. So remember that our notation here is going to be P is $7.50. Okay. And maybe I'll make a little note here, given that P is, and that's a lowercase p, right? P is $750 each logo. All right. Their graphic designer takes 10 hours per logo, right? So as soon as you say per logo, that's going to be your variable cost, right? And they charge $35 per hour. So your variable cost is going to be, it looks like we only have one variable cost and one fixed cost, right? And so in this case, it's just going to be the 10 hours at $35 an hour. So it's going to be 10 times $35 per hour times X, however many logos I'm producing. And then I'm going to say, well, my fixed costs are going to be $10,000. So let's see here. All right. That is all the information that I have. And what we'll find is that it's all the information that we need. I'm going to bump this down because what I want to do is the variable cost is actually, it's going to be 350x. Right? I just want to simplify that before I plug it in. Okay, so one or A, I don't know, typesetting error. So part A, we want to find the profit function. So like I said, you want to kind of start, and I'm going to grab this again. So this is what we want to build. We want to build a profit function. Right? So this is where I'll start, number one. And then what I'm going to do is I'm going to replace the total revenue with P times X. Okay. That'll be my second step. How about? My third step is going to be to replace the total cost with the variable cost plus the fixed cost. remembering that you're subtracting all of that, right? So you do have to bring that negative inside. And then my fourth step is going to be to replace the variable cost with the specific variable cost. Or, yeah, I guess like that. Right. In my mind, I start down here and I kind of bloom out, but I guess really what's happening is I'm funneling all the things that I need into the profit function. Doesn't matter how you think about it, but we need to kind of massage this section of the formula sheet until we have a profit function. So what I'm going to do is I'm going to start with the profit of X is the total revenue minus the total cost. And when I do these, I always I start with the plain old function and then I always build it up, right? It's just a nice, it's a little bit longer, but it's just a nice way to make sure that you're covering all your bases. So I always go through these steps. The total revenue I'm replacing with P times X. In the same step, I'm going to replace the total cost with the variable cost plus the fixed cost. Oops. Making sure that you have brackets around here because this minus is on both the variable cost and the fixed cost, right? You don't want to, and this is a really, really common mistake that I see, is you forget to put the brackets around or expand the negative in. And then you end up adding your fixed cost to your profit. In this case, you'd be adding $10,000 to your profits that you're calculating, which would be very wrong, right? You paid that, you didn't get that. So then what I can do is, okay, I can expand this out. So I get PX minus VC minus the fixed cost. And then what I'm going to do finally, right? So I've got this one under control. I've got that incorporated. I've incorporated the total cost. The only thing that's missing now is the variable cost, which I can replace by C times X. So I have PX minus C, capital CX minus the fixed cost. Notice here, I can collect like terms, right? I've got a common multiple of X here. And so what I can do is now I don't want you to get confused here. You can just leave it like this, right? This is correct, right? I'm just trying to simplify it a little bit. But you can leave it like that if you want. Then I have X times P minus C minus the fixed cost. Where did CX come from? I'm replacing the variable cost here. So the variable cost is getting swapped out with C times X, which is the cost per unit times the number of units. Awesome. Okay, so this is my profit function in general. And notice that because nothing changed on the left-hand side, I just left it as it is. But so now what I'm going to do is I'm going to write out, I'm not going to write it on every line, but the profit of X is going to be X times P minus C. This is our general profit function. This is our general profit function. So what you can do, right, is you could start here if you wanted to, right? If you're building a profit function, you can just start here, but I want you to be able to build up this profit function, right? To be able to build up this general profit function using the formula sheet, okay? But ultimately, if you want to have this on some sort of, I don't know, cheat sheet or something to the side, especially for the test when you have to use this stuff, maybe it's nice to have the formula handy, right? It is open book, so you can have stuff like that handy. But I also need you to be able to develop the general profit function, right? But we're allowed to just use it from here now, okay? So, all right, so the profit is going to be the number of items that I've made or sold, right? And then the price that times the price that I charge for each item minus the cost to make them. And then I need to subtract the fixed costs, right? I need to subtract the fixed costs. I don't want to be adding them. So you want to just really check yourself there. Okay, so in our case, we know some stuff, right? We know P is 750. We know capital C is 350, and I'll emphasize that here, right? So here, C is 350, and then the fixed cost is 10,000. Okay. So in my profit function, what I end up having, once I plug those values in for this problem, I get the profit at some number of items, X is X times 750 minus 350 minus 10,000. Right? Just using the information that we have and plugging it in. Now I can simplify 750 minus 350. Should be 400, but I'm feeling a little, ugh. 750 minus 350 is 400, good. So then what I've got is I can say, okay, well, X times 400, I'm just gonna write it as 400X. Usually I like to have my X on the right-hand side if it's times a number. So, and then minus 10,000. Okay. There will be questions where it's going to be beneficial to leave it as 750 minus 350, but for now, let's just simplify it to 400x. So sometimes it's going to be easier to solve the problem, depending on the problem, if you have the profit function like this. So what was the question? So we found the profit function. Wow. There. We have our profit function. The next thing we want to do is we want to calculate the profit that results from designing 10 logos. Okay, so now my X is going to be 10 and I want to find the profit. Okay, so I'll call this part B. What it's asking me to find is the profit of 10, right? Remember, we use this function notation to say, okay, I'm letting X be 10, all right? So that's 10 times, or maybe I'll use the simplified version, 400 times 10 minus 10,000. 400 times 10, again, little mushy here, is 4,000 minus 10,000. This one I can manage. A negative profit, that's a loss, right? Loss of $6,000. And here I tried to avoid using the commas because I know it marks it wrong in Moodle, but it's more for readability, right? And so I like using the commas. Okay. Oh, hi. This dog is being so needy today. She usually just sleeps through. Naughty girl. Yeah, she's a bad girl. All right. So, I would pick her up and show you, but she's really darty. What about the other? Oh, so this 10, let me go back there. This 10 here is not, so it's important to remind yourself that you're not multiplying by 10, you're finding the profit at x equals 10. Okay, so I'll write that down because that's going to be really important, right? This is the profit at x equals 10. So you don't want to confuse yourself. Good, yeah. By treating it as 10. So you want to, in your mind, keep straight which one is the function and which one is multiplying. But yeah, no, that's really good. All right. Part C, usually we kind of flip the script here and we say, okay, well, what if I want to make $8,000 in profit? How many logos do we have to crank out, right? So now I'm told what the profit should be, and I'm asked how many logos do I need to make? Well, that's solving for X, right? So now I'm given the profit and I need to find X, the X that makes that happen. So we can use the profit function again. I'll put it on the new page. So we've got the profit of X, and because it's on the next page, I'll just write it down. 400 times X minus 10,000. So now I'm forcing this profit to be 8,000. 8,000 is 400X minus 10,000. And now I want to find how many logos make this happen, make a profit of 8,000. So solve for the number of logos. The math here is not bad, right? You're solving for X, you have to add 10,000 to both sides and then divide both sides by 400. That's not the problem. The problem is reading these questions and saying, okay, so how do I need to set this up, right? That's the hard part. The math is fine. So we have, I'm just gonna do it 18,000, right? 8 plus 10,000 is 18,000. Is 400X. So X is going to be 18,000 divided by 400. Remember, I like to do that revolving door and just kind of switch things around. X on the left-hand side, dividing by 400 in the same move. 18,000 divided by 400 is an even 45. That never happens. For that reason, what if the answer was say X was 45.2? How many units do you have to produce to get a profit of 8,000? 45 would be slightly less than 8,000, right? You can't make 45.2 of an item and sell it, right? So you have to think about, okay, well, what does this mean? It means I would have to make at least 46 items, which would give me slightly more profit than 8,000, right? But that's better than making slightly less, right? So just be careful. Yeah, so usually you round up it depends on the scenario, right? So you have to think about, you have to round up if you want the profit to be at least 8,000, right? Depending on, so the Moodle might not be that clever. It might not, so it would probably just take x equals 45.2. I'll have to check, but I'll make a note, just like I did for the quiz, about things to keep in mind for when you're answering. I'll check it out and see how it's behaving. But for us, when we're talking about it, right, if you went to your boss and you said, oh, you'd need to make 45.2 units, your boss would be like, well, how am I supposed to make 0.2 units? Oh, right, make 46 then, right? So, and that's just from how we understand, okay, the more we produce, the more profit we make, right? And so we understand that rounding up is the way to go. There are scenarios where rounding down would be more appropriate, but I know that's not helpful. In general, round up to the whole number. There, like it never happened. In this case, right, it gives us a nice, beautiful 45 even number. Great. Okay. Good. So that's our first stab at a profit function. How about another one? Oh, okay. I like this one because it makes us kind of work with the profit function a little bit without building a profit function necessarily. So if a company makes $2,000 profit from selling 100 units, okay, and $10,000 profit from selling 150 units, hey, that's quite the jump, right? What are the fixed costs? Okay. So, we know the profit and we know the number of units. Okay. And we want to know the fixed cost. So even though it looks kind of like a quick question here, it's actually quite involved. There are going to be many ways to solve this, or many ways to go about solving this, right? Just depending on how you like to solve things. This dog is out of control today. I gotta show you guys. She's a bad girl. Why are you so busy today? So busy. Yeah. She's had enough. She's sick and tired of it. She doesn't want to teach anymore. She doesn't want to learn anymore. She's studied a lot. She's done her master's in statistics. Done a lot of school. Anyways, today she's had enough. So let's just break down the information that we have and just kind of see, but really what we're trying to solve for here, we're trying to solve for FC, right? So what we're told, and maybe what I'll do is I'll underline it in different colors. Here, the first thing I'm told is that the profit at 100 units, the profit of 100 is 2,000. Okay, so that's how we would summarize that information mathematically. And then I'm also told that the profit from selling 150 units, the profit at 150 units is now $10,000. And I'll put a comma in there just to emphasize. Oh, a heads up, if you're European or went to French immersion, you would probably use decimals instead of commas, but for us, we use commas. So, all right, that's a side note, but it is important because otherwise it gets confusing. All right, and I know if you took French immersion, you'll probably want to put the $ afterwards. Yeah. But we do the $ in front, and those are just things to remember. I know that from years of students being confused and then finally I'm like, were you in French immersion? And that'll mess with you. Okay. So, okay, so what we have is we have these two profit functions, right? You're out of control today. You're out of control today. Hang tight. We've only got 10 more minutes. So what we can do is we can set up these profit functions, and let's just go ahead and use that general profit function that we developed earlier. Okay. So I'm going to cheat. I'm just going to copy this. And maybe I'll put it properly on the line here. There. So what we have two profit values, right? But we also have two values of X. So what we can do is, okay, I can replace this profit of 100, right, with, and I know the X for this value. It will confuse you a little bit because you've got P minus C, but the P is the same, right? The price that you're charging per unit is the same, and the cost per unit is also the same for each of these scenarios, right? And so what's going to happen is they'll cancel out, okay? So what we've got here is we've got the profit of 100 is 100 times P minus C minus the fixed cost. Okay, and in fact, I'm going to swap out the profit of 100. I'm just going to write it out as 2,000 right away. Save us a little bit of explaining. Okay. So then what I'm going to do is actually maybe orange wasn't a good color to pick, but anyways, I'm sticking with it now. What I can do, because the fixed costs are going to be the same for each of these scenarios, right? And so what I can do is I can solve for the fixed costs in both of these scenarios. So I'm going to add the fixed costs over here, and then I'm going to subtract 2,000 from the right-hand side. So what this ends up looking like is 2,000 minus the fixed costs is 100 times P minus C, just kind of ignoring the fact, oh, sorry, plus like fixed costs when I move it over. Sorry, guys. Right, and so I can move this fixed cost over here, and then I'm going to subtract the 2,000. And just ignore the fact that you don't know P minus C, and just convince yourself, well, that's the same in both of these scenarios. So, so I can probably work without knowing it. So then I have my fixed cost is 100 times P minus C minus 2,000. Okay. What I'm gonna do the same thing with the pink one. So the profit at 150. Oops. The profit at 150. At 150, I had a profit of 10,000. Replacing X with 150 now. times P minus C minus the fixed costs. So again, I'm going to solve for those fixed costs, and the reason is because this fixed cost is going to be the same as this fixed cost. It's still the same company, it's still the same scenario. We've just produced different amounts. Right? And like I said, there are many ways that you could go about solving this, right? So maybe sit down and try to solve it yourself, but this is how I go about solving it. I think it's the easiest way, but I don't know, try it. 10,000 plus the fixed cost is 150 times P minus C. So then the fixed cost here must be 150 times P minus, oops, capital C, minus 10,000. Okay. This fixed cost and this fixed cost must be the same. So what I'm going to do, right, and this is where it gets a little bit weird, at least for the first time that we're doing something like this, right? So here I've got a fixed cost, and here I've got a fixed cost. You might remember when we were solving for the equilibrium price and quantity, right? We had Q equals something and Q equals something. We just set them equal to each other, right? And so we're going to do that exact same thing here, just a little bit more complicated. And so I'm going to and I like using the color scheme to emphasize that things are where things are coming from, okay? And so because I'm on the pink pen, I'm going to go 150 times P minus C minus 10,000. Oops, 10,000. Because I couldn't decide which color the equal sign belonged to, so I'll use dark blue again. And then the fixed cost for the orange was 100 times P minus C. Oops, capital C, minus 2,000. What we'll see is we're going to be able to solve for P minus C as if it's one thing, right? That's the only variable that I have here. And then I can use it in either one of these formulas. It doesn't matter. The P minus C will be the same to find the fixed cost, right? So very similar to solving systems of equations. In fact, we are solving a system of equations. And the equilibrium points and the points of intersection, et cetera, et cetera. All right, so now I'm going to switch to just all blue because otherwise it'll be too messy. I'm going to add 10,000 to both sides, just kind of moving things around here. So I've got 100 times P minus C minus 2,000 plus 10,000 is 150 times P minus C. I'll subtract the 100 P minus C over, right? Remember to treat P minus C as if it's one thing. It is just one value, right? So we have 8,000, and maybe I'll try to stack my equal signs again. 8,000, negative 2,000 plus 10,000 is 8,000. Is 150 times P minus C minus 100 times P minus C. Right, got a common multiple of P minus C, and I'm speeding up because I've got limited time here, times 150 minus 100, or if you just went to 50 P minus C, that's fine. 8,000, 8,000 on the left-hand side. So then P minus C is 8,000 divided by 50. Uh-oh. 160. So then P minus C is 160. Therefore, the fixed cost, and I can use either one of these to calculate it, right? Is 100 times P minus C. P minus C as a whole is 160 minus 2000 is, 100 times P minus C minus 2000, which is 100 times 160 minus 2000. All right, 16,000 minus 2,000 is 14,000. Or if you prefer, right, the fixed cost was 150 times P minus C minus 10,000. I'll do this, this math a little bit faster, right? But 150 times 160 minus 10,000. If you go through the same song and dance, 150 times 160 is 24,000 minus, oops, I almost did 20,000 minus 10,000. Again, they should be the same. They are the same, right? So then the fixed cost must be 14,000. And with that, I'm out of time, but definitely have a look at the rest of these examples that I've got, and we'll work through these next day. Just so we'll be all fit for fight here. But work through these on your own to see how you would solve them, right? And then we'll work through them together. All right. Any questions before I let you go? All right. Have a great weekend, you guys, and I'll see you on Tuesday.
Thank you.